That has nothing to do with me. I thought I was going to try and work it into the talk. I even have a slide where it almost fit. But there you go. They decided to let us get that out of the way before we started. So my name's Seb. I work for Cucumber, which has been acquired by SmartBear, so I guess I now get work for SmartBear. This is a session entitled Software Contracts, or How I Learned to Stop Worrying and Love Releasing. So I almost made the mistake there. I was going to tell you that this title was inspired by the movie Dr. Strangelove. Has anyone seen Dr. Strangelove? Good. So you'll recognize, but I take it where this comes from. Dr. Strangelove was Dr. Strangelove, or How I Learned to Stop Worrying and Love the Bomb. So there's a little bit here toying in with the idea that the nuclear bomb is a bit like us pressing the release button, especially when we've got lots of microservices in place. So it's quite good to follow on from Rachel's talk about sharing and caring. Here I'm going to explore some of the techniques that you can apply to not blow up your whole software world every time you release. My agenda for today, it covers 6 areas. Sometimes when I give this talk, I do a live demo of Pact. We just don't have time today, so I will give a brief introduction to Pact. There's lots of great material online to give you to fill that space in. This is Software Craftsmanship Conference. We've already talked about test doubles yesterday. I'm going to go through this part really quite quickly. If I'm going too fast, please stop and ask me questions at any point through the talk. You might have to shout out because these lights are really quite bright, and I can see some of you, but don't wait to the end. If you've got a question during the talk, I'd prefer to deal with it as we go through rather than try and flick back through to the slides at the end. This is the test automation pyramid the way I like to draw it. This is not the way you will typically see it. It's not the way it was presented by Daniel yesterday. I don't like writing words in the middle of it because as soon as you write words like unit test into a diagram, people ask you what's a unit test. And then you find out that nobody really knows what a unit test is. Same goes for integration tests. About the only test that you can pretty much define, you can be absolutely specific about is an end-to-end test. You're testing everything, right? But that's not what we want to do, and that's not what this pyramid is trying to show. So the way I think about this test automation pyramid is it's a triangle, not a pyramid. It's a metaphor. It's trying to help us understand what we're doing in the test automation space. And it basically says the foundation of your test automation strategy should be tests that don't exercise that much of your application. So they should be focused on small bits of functionality to give you fast feedback that is easy and immediate to diagnose. And as your tests exercise more and more of the application, well, you want fewer and fewer of them. There's a link to an article that I wrote about it a number of years ago that you can find on my website. I don't want to go into any more detail about that unless anyone's got any specific questions right now. Good. It's good not to have questions this early in the talk. We also saw a diagram much like this in Daniel's session yesterday. Basically, it's a component A, which has some dependencies. You all have written components or applications that are dependent on storage systems or services that are either on the cloud or deployed locally, or other components within your system. So the dotted lines, or the A in the blue circle, is here representing a component, and the dotted lines are just the dependency graph. When you want to come and test component A, if you're going to try and stick to the test automation pyramid, you don't want to test all of this stuff over here. For a start, you don't want to test somebody else's database anyway, but your other components here, you generally want to ensure that they're tested separately. And when you're coming to try and do your test at the bottom of the pyramid, you want to test A on its own. So end up creating test doubles. Has anyone got a system that's a bit like this, where they've written test doubles? Yeah. And so the question you have to ask yourself is, what could possibly go wrong? So has anyone had any problems with using test doubles like that? And what were those problems? Shout out. The other system changed. And in the same spaces, you might have misinterpreted how that system was supposed to work anyway. So this takes us on to the meat of what I want to talk about, which is software contracts. Now, software contracts, the idea of software contracts is not a new thing. Decades ago, Bertrand Meyer created a language called Eiffel, which I'm going to make a wild guess without asking anyone to put up their hands. I bet nobody in this room has programmed in Eiffel. Oh, Oh, I was wrong. Okay, there you go. Well done. So Eiffel is a beautiful language that's almost entirely unusable and is almost entirely unused. So I'm also fairly sure that most of the people who put up their hands did it as I did back in the day because we wanted to see what it was like. My abiding memory of Eiffel is that the IDE would never work. It kept crashing, which is not a great advertisement for a language which is built on fundamental OO principles, and it introduces this idea of design by contract. So in Eiffel, contracts are first-class entities, and what Bertrand Meyer goes on to say is that the contract is an agreement between two components, so a supplier and a consumer, or a client and a supplier, and that when you enter into when you start being dependent, then you have to you do that because you're expecting some benefits. But as soon as you are dependent on somebody else or some other component to provide those benefits, you've essentially given away some of your independence, but that was the idea, and therefore you incur some obligations. You've got to use that component in the way that it's intended to be used. So this idea of contracts, it's not new in software, and it's not new in the world. Software contracts exist, and contracts in the legal real world also exist. So many of you will have employment contracts, you'll have lease contracts. These are all the same sort of things. The thing about software contracts is that there are, in fact, two aspects to them that we typically have to consider. And one is the fact that there's something explicit about it. So if you're looking at a function signature, you're seeing the explicit contract. In a minute, I'm going to go on and talk about implicit contracts. And rather than try and do that directly in using software as an example, I'd like to use an analogy of a nut and a bolt. So the explicit contract, well, what is the explicit contract between that nut and that bolt? Thread, yeah. So there are many different sorts of thread in the world. I know that most of them have gone out of fashion since the metric world came over, but there are many different threads. Someone also said size. So you get different sizes of different diameters. So those are really clear. They're really explicit. You cannot use a nut of the wrong size with this bolt. You can't use a bigger bolt with this nut. If they've got different threads, they just won't turn. You might get it on the first little bit, but it will never tighten up. That's explicit. You know immediately when you try to use it, you are breaking that contract because either the bolt will go right through the nut, or it won't fit in at all. However, there are a number of implicit contracts also. So, for instance, the length of the bolt. If in a particular context, this won't work. So these two pieces of metal here, the intention is to try and hold them together with this bolt. But because the bolt is stopped from heading into, stopped by its length here, that will never get tight, and therefore it will never be pulled together. Equally, if you've got a bolt with a shank on it, well, then you'll never get those two pieces of metal to clamp together either. These are implicit contracts. These are contracts that you need to think about the context that you're going to use the bolt in. So bearing this in mind, let's look at, I know that people have kept saying that you're mainly Java programmers, but I'm sure that C# is probably within your realms as well. So what's the explicit contract here? Yeah, so it's the type, it's this signature. So what it says is that the method add, if you pass it to integers, is it going to return an integer? So what are the implicit contracts? They're your value, okay. That it will be a sum. Doesn't cause a stack overflow. It's not going to throw an exception. We're not going to get, you're not going to roll over, have an arithmetic overflow as well. So the point I want to make here is that a lot of the contracts that get that our IDEs help us see, a lot of the ways that we consume microservices in the way that the documentation that Rachel was showing us earlier, that documentation often shows us the explicit contract. It lets us know exactly how it will definitely fail, but it doesn't always give us the implicit contract. Now, I'm guessing that TES probably do document down to a certain level of detail around the implicit contracts, but it's not always enough just to look at the code. You actually have to know what's going on in the runtime underneath as well. This is a problem because we really need to ensure that when we create a test double, it behaves exactly like the component that it's replacing, especially when things are going to go wrong. So it's fine for a test double to behave in the way you want when things are going right, but if when systems begin to fail and data begins to go bad, your test double isn't working in the same way as the real component does, then when that outage happens that Rachel was talking about, your system might behave in a really unpredictable way because you'll have tested it using the test double for working in a bad way, but you may not be testing it against the actual occurrences. Yeah. So the question was about the integration tests, testing the explicit component and the interaction between the component A and the thing that's dependent on. And actually, it's the error cases where that's really hard to do. Because as I think it was Daniel yesterday who was explaining, it's very difficult in some cases to generate errors for external components. There are some external components where you don't get access to those third-party systems in an easy way. So what we're trying to do with the test doubles is do as much of the testing and get as much confidence that our component A works in the way we expect without needing to rely on those integration tests. And that's, to some extent, why we also have that pyramid. That pyramid is telling us that we want fewer integration tests. We're certainly going to want some of them, and we will certainly use integration tests wherever appropriate and wherever possible. But when it comes to error cases, it's sometimes extremely hard, if not impossible, to generate that situation. And at that point, you want your test double to accurately reflect that error case. So this is where contract testing comes in. Contract testing is another suite of tests that tries to ensure that your component acts, your test double acts in exactly the same way that your test double is working in the same way that the dependency it's replacing behaves. And a common approach, if you were to do it from first principles, is that you write a collaboration test which exercises component A, and it uses test double to replace the dependency. And then when you move into production, modulo the fact that you might have done an integration test at some point as well, but when you move into production and you work with the same situation takes place against component A and it works against the actual dependency. So what we're trying to do here is that the collaboration test expects the test double to behave in one way, and the production system expects the actual dependency to work in exactly the same way. And these two dotted arrows represent the actual collaboration. So A is collaborating with the test double to provide simulation of the behavior that the actual production system will provide. And when they both pass, as in our collaboration test pass, and this may be a unit test or it may be an integration test, but when the test passes, we expect then when we release that into production, the same situation takes place, that production works fine as well. And this is ideal, this is success. If the collaboration test fails, if your unit test fails in this particular behavior, then you would expect if you release that component A into production and you replayed that behavior, it would also fail in production. The embarrassment happens when it passes on your desktop and it fails when you release it into production. I'm guessing that many of you have had this experience, and this is something that we would like to avoid wherever possible. And the contract tests come in here. The contract test is itself a test, but it's a test that will run both against the test double and against the system that you are stubbing out with the test double. So what we're going to do is we're going to run the contract test against the test double on a regular basis, and we're going to run the contract test against the production system also on a regular basis. We may get into talking about whether those cadences are exactly the same later on. I think one of the main challenges with contract testing is it's never really been documented. I should point out to anyone who's taking photographs, you're welcome to take photographs. However, the slides are already online on SlideShare, and I'm sure they'll be made available by Software Craftsmen London as well. So one of the main problems I've found with people adopting collaboration contract testing is that there's very little documentation about it. I haven't come across a great book about it, and the only really good source that I've come across is stuff that J.B. Rainsberger has written on the Growing Object-Oriented Software mailing list. And this particular extract comes from 2012, so it dates back a bit. There's some really great stuff on the Growing Object-Oriented Software mailing list. It's a book that I don't think has been recommended so far at this conference, so I'm gonna have that honor. If you haven't read Growing Object-Oriented Software Guided by Tests by Nat Price and Steve Freeman, now's a great time to add it to your Christmas list. Anyway, so what JB was explaining in the mailing list all those years ago was that we need to, if you're going to do contract testing, you need to be systematic about it. And he was talking about systematically in your working practice. So he's not talking about any special tooling. And what he basically says is that every time you write a unit test, and you're stubbing bits out, you are making assumptions about the contract that your component is entering into with the component on which it's dependent on. And the idea of the contract test is to justify or give yourself confidence that those assumptions are true. So I'm going to walk you through contract testing from first principles, doing it in C#. And so this is a one implementation mechanism for writing a contract test. So your contract test will access whatever service it is in the component on which you are dependent via an interface. And this interface will be implemented both by your test double and also by your external component. So to be clear here, I'm not suggesting you have to go to S3 and tell them that they've got to implement your interface. That's not going to happen. What you need to do is you need to wrap your access to dependent services or dependent components in your own interface. This is generally good practice. I don't know if you're familiar with a London-based consultant called Joe Wallens, but he said some very wise words a number of years ago. That's a very short sentence. It's quite easy to get wrong, but the way it goes is, don't mock what you don't own. It's really important that if you're going to start stubbing things out, you start stubbing out interfaces that you own, so that you only expose to your code the functionality that it needs, rather than, I don't know, I've seen people try to stub out HTTP requests. You don't use the whole of HTTP requests. You don't want to rely on that. So just narrow it down, create an interface that exposes exactly the behavior that your component needs, and then you can use that to wrap whatever external dependency that you're using, and you create equally another implementation, which is your test double. So we're going to talk about the actual the contract to start with. So we start off with an explicit contract, and we say, well, we're going to call it the revenue provider, and we have a method called getRevenue. It's going to take a customer ID, and it returns a decimal. So this is an approximation of trying to get revenue from an external system based on a customer ID. So that's our explicit contract. We know that we pass in an integer and we get out a decimal. But what's our implicit contract here? What other things should we consider? Exceptions. Based on the vast experience that we have in the room, what might be a simple way of generating an exception by calling a method like getRevenue with a customer ID? Invalid customer ID, exactly. So what would happen if you passed in an invalid customer ID? We don't know, right? This is implicit. We need to know this. If we're going to write a test double, we need to know what exception type is going to be passed back. There's also questions about the magnitude of the value that's returned, to what precision it is. But we're not going to consider that to a great deal of detail. Really, I want to focus on the fact that there are things that you need to understand, you need to get correct when you do your test double implementation, but that are not explicit in the contract. So then we'll think about how we would implement the contract test. And the way a simple way of doing it is by creating a test fixture as an abstract class. This contains the actual contract itself, and it has a private interface reference, which could either take a value of the test double, or it could take a value of the production dependency that you're stubbing out at the moment. And we add here a setup which goes down to the derived class, which we haven't looked at yet, to get the implementation of that interface. And then we start having the tests which define the actual contract itself. So one at the top is quite easy. It just says it says valid customer ID. So this is the behavior that we expect from a valid customer ID. Note that despite what was said earlier on today, this is a test that has no assertion. You may not like it like that, but essentially I don't want to check that I'm getting any particular value back, because when I'm running against the production system, I'm not going to know what the revenue is, or rather, I don't want to have to care about what the revenue is. What I want to know is that if I pass in a valid customer ID, no exceptions are thrown, and something gets returned. And I know because that this is a strongly typed language, it's going to be a decimal, because otherwise it wouldn't work. And then the second test here is invalid customer ID, and I'm asserting that it throws a customer ID exception. And there I'm making clear that this is the behavior, this is the contract that I've entered into, and this is the behavior that I expect, that the component on which I'm dependent will throw this exception if it's passed an invalid ID, and I expect my test double to do likewise. So this is the abstract class. These tests define our contract. And there would probably be more of these tests, but it's these tests that actually document the contract between component A, or the component that you're using, and the component that you're dependent on. And now if you look at the wee schematic in the top right, now we're looking at the actual implementation of that contract test. This is for the production contract, and you'll notice all you have to put in it is you override the get revenue provider method and return a production revenue provider. And likewise, there'll be a test double contract, and the only difference is it returns a test revenue provider. So it's really simple. What we've got here is one contract defined in an abstract test fixture with two derivations of that, each of which simply provide an implementation of the interface through which you're going to access your dependency. And in this way, you're able to test both the test double and the dependency that you're stubbing out with the same tests, without having to write anything twice. Is that making sense so far? Yeah? Okay. So, now I've talked about contracts so far, and what I'd like to do is, and I talked about implicit and explicit, but there's also a subtlety in contracts in the difference between producer contracts and customer-driven contracts. And customer-driven contracts have had quite a bit of press over the past few years, but it's worth calling out what they actually are. So, provider contracts are the sort of contracts that are foisted upon you. So you will not change HTTP request, right? It's very unlikely that you'll be responding to RFCs and changing the way the internet works. There are lots of big contracts that you just have to live with it, because they're created by consortiums of organizations, and that's the way it goes. And there's a lot of words here about it, but that's basically all that this text is saying. They're closed, they're complete. You have to use them in whichever way they're packaged. You either like it or lump it. And then there are consumer-driven contracts. And what they say is, well, actually, the producers, the people who are going to create the component on which you're dependent, are going to some extent, respond to your requests. So what you do is you create contracts about how you would like how you expect to interact with that component, and then you try and collaborate with the providers of that component, and they may or may not satisfy your requirements. It's not saying that if you ask for, and Rachel also mentioned this about adding access methods to a component to satisfy one consumer's needs. So TES refused to do that, or are unlikely to do that. And it's true of most components. If you ask an open source tool to provide a new API and it doesn't fit with the direction they want to go, and they'll just say no. So consumer-driven contracts is not about the consumer having control, it's about the consumer specifying how they expect to use the component and using that as a way to communicate and collaborate with the providers of that component. Because agreeing what the contract should be is hard. Again, a number of people have talked over the past few days about having small teams, and we talked in the panel about closing the gap and having fast, high bandwidth communication between people that work together. And that works fine when you're co-located or when you're in a small team and you speak to each other each day. But there have been a number of bits of research that say if you're more than a certain number of meters apart, it's as if you're in a different time zone. That it's quite easy to separate people and make it much harder to make those sorts of agreements. So some of you may be unlucky enough to work in environments like this, but equally the folk that work in medium-sized organizations might have a building which has more than one floor, and so the provider is on a different floor from the consumer team. I've worked extensively with a bank in the United States who've got a campus, which has overflowed the campus, and so it's got buildings in the campus and buildings down the freeway. And at that point, trying to coordinate changes means a lot of effort, especially if you don't even know who the provider is. And then finally, you will find global organizations where you've got consumer teams all over the world. And at that point, you throw in the time zone problems as well. This is just the way the world is. What we're talking about today isn't trying to change any of that. It's just trying to cope with it in a sensible way. These problems were significant even before microservices came along. But with the advent of microservices, I believe that it's become a much more significant issue. So you think of continuous integration. You check in and it goes through the CI build, and then something happens and it gets promoted through maybe a number of environments and maybe goes to a staging environment, and then eventually ends up in production. So this is a shortcut. I could put many more stages in here. I'm sure that many of you have CI pipelines with more than 3 stages in it. So think of the middle stage here as being 1 to n stages, whatever works for your organization. And what this diagram is basically saying is that there'll be a version of component A in production. There may well be a different version in staging, and yet another version that you're currently working on and it's being checked in to your source control system. And if you've got a consumer and provider, so some of you will notice that the A has changed to C and P. So this is C is short for consumer, P is short for provider, and we've got this idea of the versions or the iterations of these pieces of code moving through the stage of your CI pipeline. But do you want them to move in sync? Do you want to have to promote C2 and P2 into production at the same time? If this was the United States, I would encourage you all to go, hell no, right? This is absolutely what microservices is trying to get around, trying to decouple these different behaviors, these different sets of functionality. So if you are ready to promote P2 because you've done all your testing on it, you're comfortable that it should be promoted because the business logic that you have written is safe. What checks do you have to make against component C, and which versions should you check against? It's quite complex. You've got to do a number of different checks before you can be sure that your component doesn't just work against the version that it's sitting in staging with, but it works against the one that's in production, or at least in the next stage that it's going to move into. Because what you don't want to do is to have your promotion breaking the next environment because you didn't have a chat with you weren't sure about what had changed in the thing that was either dependent on you or that you were dependent on. So this is C and P, consumer and provider, and that makes the space really neat to talk about because we've only got two things here. But how many microservices did you have, Rachel? 150, 200? You know, and I'm sure that they're not all talking to each other, but I'm sure they're not all just dependent on one other service. So there's going to be, you know, your consumer here may be dependent on, you know, 5 providers. That wouldn't be unreasonable. Now imagine this graph if you have to check against 5 different providers in multiple environments before promoting. And then you've got, you know, new components coming in. You've got things that are moving very fast, and some things that are moving very slowly. And the thing here is that if you were to roll this all by hand, you would be working very hard trying to keep up. And I think to some extent that's why contract testing, I think to some extent that's why contract testing never caught on, even when we were in a much more simple world, because we want people initially start by going, we've not got time to write automated tests anyway, right? So this is the SC London conference, and I'm sure that most of you are writing automated tests as you do your development. But I don't know if it comes as a surprise to you, the majority of teams in the world do not do that. And one of the reasons they quote it for not doing that is they just don't have the time. Now, clearly that's a mad way of not writing automated tests, a mad excuse for not writing automated tests. But if you then tell them that actually you should, for every stub that you put into your unit tests, you should write a suite of contract tests to ensure that your assumptions are valid, that's more effort, and it makes it much harder to convince them. So for my money, this is why contract testing hasn't caught on. And I wonder, you know, this is obviously not scientific, but how many people in this room do contract testing or have contract tests around their test doubles? Okay, it's less than 10%. It's a smattering. With microservices, this is a quote from Beth Scurry, who created Pact. And she says, if you can't deploy your services independently, you don't have microservices. You've got a distributed monolith. And actually, this is it's a great quote anyway, but I think it actually it puts the myth for me to the difference to the fact that distributed and monolith are opposites. I think they're actually they're different dimensions. So a monolith, in my mind, talks about how many pieces you need to deploy, and the microservices is talking about how independent they are in their deployment. So they're not actually talking about the same thing. So you can have a distributed monolith, and you can have anyway. So, which leads us on to Pact. Who's used Pact? Quite a few folk, okay. Actually, maybe the same number of people that were using contract testing. That wouldn't be altogether surprising. So the idea of Pact is that it does all of the heavy lifting for you in writing contract tests. Now, it's specifically targeted at a sort of component that you're dependent on, and that sort of component started off being just web services. They've extended it to event queues now, and I'm sure Pact has now it's an open source project, but it's also now turned itself into a commercial organization doing hosting of the various Pact services. So I'm fairly sure that they will grow the breadth with which they of offerings that they give you. But essentially, it's a way of specifying using a DSL a contract that your consumer expects the provider to satisfy. And then when you use Pact or you run your tests, that DSL generates generates JSON, and the JSON describes that interaction. So it describes the interaction that the test that you ran expected from the provider. And where it comes in really useful is that you can then take that JSON and you can give it to Pact and ask it to run those requests against your provider and assert that what gets returned is exactly what your consumer had expected. So in a decoupled way, it uses a language-independent JSON representation to describe a contract, or describe the contract, the subset of the contract that the consumer is interested in, and then pass it to the provider team and have the provider team verify that their provider actually does satisfy that contract. Now, if the provider team verify that it satisfies the contract, that's great. But if it turns out that it fails, as in it doesn't satisfy the requirements or the way that the consumer has described it, now you're in a situation where you have immediate actionable information to facilitate a discussion or communication between the consumer and the provider team. Obviously, the simplest thing to do is for the consumer team to change its expectations so that it's more in line with what the provider has. But equally, you could get on Zoom and try and discuss with the provider team what you're looking for and whether it's something that's likely to happen. So there's some key points about Pact. It's the consumer that creates this subset of the contract. It does this using the Pact DSL. And the Pact DSL is available in several languages. And essentially, the Pact DSL runs at the same time as your test automation runs when you check into CI or when you run your tests at your desktop. As the Pact runtime kicks in and your tests are running, it spins up its own little mock HTTP server if you're testing against an HTTP server, or likewise, it does a similar thing for event queues if it's events that your external dependency is dependent on. The Pact file is created in JSON, and then that Pact file needs to be given to the provider team so that they can verify that their component works in the way that you were expecting. That in itself, if you're working in a small team or in a small organization, then you may have a shared folder for doing that. You may do it using S3 buckets. It's just a JSON file that needs to be moved around. But clearly, we would want to automate that, and that's exactly what Pact team have done. So they've created something called the PAC Broker, which begins to add, flesh out those requirements of flesh out the functionality that we really need to be able to deploy those microservices in the way that we were talking about earlier. So consumer CI, when it runs, will generate that Pact JSON file that describes the subset of the contract that is needed for the tests of the consumer to pass. If this test run fails, nothing happens. Your CI will just give you a failure, and you know that you've got to go and fix your own code. That's just you. But if the CI build passes, then what you put into the CI is publish the JSON file that was generated to this central component called the PAC Broker. So the PAC Broker is another service that it either runs on your local network, in which case you're responsible for it, or it runs on the Pact website, which is a paid-for service, but at least then you don't have to worry about upgrading it and keeping it running. So you publish it to the PAC Broker, and that then enables providers in their build pipeline to pull down any contracts that specify them, that says we're dependent on you, and run those contracts against its implementation to ensure that the provider and the consumer would work together. Again, this is a very simplified version of it because it looks more like this. It's still not hugely complicated, but so the consumer CI, it runs, which creates the JSON file. That publishes the contract to the PAC broker, which fires a webhook to the CI for your provider. Provider will then fetch the contracts down. The CI will run the tests using those JSON files, will verify that they have passed or failed and publish the results. Another webhook will then ping your component, and you can use that to promote your your component, should you so wish. So this workflow is one potential workflow. It's just a tool. You can use it in any way you like. But the way they've tried to do it is in a way that you can specify what testing you want to take place and what actions you would like your CI to take if it passes, and what actions you would like your CI to take if it fails. And it's got some funky stuff in it, which is if nothing's changed, it doesn't do any of this. So it looks to see whether the JSON changes. Yeah. So the question was the Pact JSON definition materialized, or is it dynamic? So it follows obviously a schema, but it's generated when the CI runs. It actually generates a physical JSON file in the file system, and that file system then gets transmitted by a web call up into the broker, where it gets stored. Was that your question? So the question there is there one place where this definition is, and the definition is the DSL that you wrote in your unit tests. So when you write your unit tests in the consumer, you say in the same way that you would if you were using a Mockito or something like that, you'd say if it receives this parameter, then it's going to return this value. So you express that in DSL. It talks about what's in the body, what's in the header, what the return code should be, and what the body of the return should be. And that's also expressed in the DSL. So it's actually in your code where you express how you think that the provider should behave. And then that generates JSON, which is obviously is the interchange format. That goes up to the broker. The provider pulls that JSON down. It then passes it to Pact, and Pact then makes web calls based upon that. So the actual specification is in your code, and it's written using a nice DSL. If I finish in time, I might be able to show you some. But anyway, there's some nice. There are some very good example projects up online as well. So this is just for one build. So here, what we're talking about, this is the CI for the latest version of the consumer that you've checked in. But of course, that previous diagram that I showed with multiple different components all going through your CI pipelines in parallel, this isn't sufficient. And so what PAC Broker does is it maintains the matrix. So it's not a very exciting name, and it probably isn't the best name for it, but that's what they called it. And basically, it's basically got a huge table where it talks about component name and version number has been tested against component name and version number, and this was the outcome, either verified or failed. So here I've simplified it somewhat, but so consumer version, it would be what was generated. That was the check-in that would have generated the JSON file, and then this is the version that it's been tested against. And because it records the version number of each component and it records the outcome, you only need to run version 11 of the consumer against version 31 of the provider once, and then it caches that value. And now you can keep pumping things through your pipeline because you only ever build the binary when you check in, then it's the binary that's being moved through the pipeline. Because you never change that binary, you can just go back to this matrix and decide whether it's safe to deploy version 12 of the consumer against version 31 of the provider. And it clearly tells you here that it's not. And they've obviously done their stuff, and they've created yet another little wee tool that sits on top of it, which is handily called Can I Deploy? And Can I Deploy essentially looks at the versions of the components that are in production, or whichever environment you want to deploy into, and the version of the component that you are thinking about promoting. And it looks into the matrix and says, well, are all the versions of the components that this component depends on, or is depended on by, are they all, will it work? Have we tested it against all of the versions that are in production? And if the answer is yes, which is a quick lookup, then you can promote it to the next stage of your pipeline. And if the answer is no, well, then it will stop and wait for you to do something, some remedial action, which might be to upgrade another component in the pipeline, in production or in the next staging environment, or it could be to go back and change something. And so these different components fit together to give you a toolkit to automate your microservice pipeline and give you confidence that when you're promoting a component, it's not going to break anything that depends on it, and it won't be broken by the fact that the dependencies that it has are unexpected. Maybe we should. Could I get the microphone, please? No. Let's do it now. That's fine. Thank you.
Hi. So, if you've got a service, a consumer that consumes like multiple providers, and you write tests for how you expect those providers to behave, and then you deploy that, you generate your JSON file, and then you put that in your broker. Does that automatically then work out what the dependencies of that consumer are and populate the matrix, or do you have to configure that yourself? Or
Yep, good question. So it will actually generate a different JSON file for each dependency that your consumer has. So for each provider that your consumer is dependent on, and you put that in the DSL. So in the DSL, you're saying, this is the component that that I am describing. This is the behavior of that component that I'm describing here in this DSL, and it encodes that into the JSON. So when the JSON goes up, it's self-describing. It says which component it's working against. It won't say at that point necessarily, it won't say what version it's working against, because of course the consumer doesn't know what version is going to be in production. It just says I'm depending on this provider, and then what the PAC Broker will do is it will allow that JSON file to be brought down and run against any version of the provider, and you need to configure in your CI which versions do you want to run it against. You clearly want to run it against the one that's in the next stage up. You might want to run it against production as well. Yes. There's another microphone coming. Thank you.
Does it integrate with Azure DevOps pipeline of release deployment?
Does it?
Does it integrate with Azure DevOps pipelines?
It's all command line stuff, so you can
PowerShell it in.
Yeah, you will be able to stick it in some. I mean, I'm not familiar with Azure pipeline, but I hope there's an execution environment where you can do scripting, and if they definitely use it in .NET. So I guess my answer has to be I don't know. I hope that Azure pipeline will allow you to do that. Does anyone know in the room? Yeah? Yeah. Okay. It will run the command line. So the PAC Broker key points. Pacts are published by the consumer. So these JSON files, yeah, I really didn't mention it, did I? These JSON files are called Pacts, but they're not contracts as such, because they're just subsets of the contract. These are the Pacts that essentially we're saying, I have a pact. I would like the provider to have a pact with me that it will behave in this way. So the pacts are published by the consumer, they're fetched by the provider, the results of the running of the verification of that pact against the provider is stored in the matrix, and the matrix supports independent deployment because it keeps it keeps a record of every time a verification has taken place, and every time you publish a pact, it will kick off verification in your provider pipeline. And so the takeaways, if as such they are, is that I believe that contract testing, whether you're using Pact on microservices or using contract testing for components, increases your confidence in being able to release. Specifically with regard to the question about integration tests earlier, it reduces your reliance on integration tests. Because what you're doing is through the contract testing, you are verifying that your understanding of how that thing you're dependent on works, and now you're codifying that inside the DSL, which means that you don't have to spin up those external dependencies on such a regular basis. It speeds up and decouples development. Because now you are communicating with your provider via these JSON pacts, you can certainly work on a component before anyone even starts working on the provider. Now, that might not be a clever thing to do, but you are decoupled. Your tests express how the providers should behave. Your JSON files document that. And when the provider team is ready to work on it, they are there to help guide them. Now, obviously, if you run too far ahead and the provider then says, no, we're not going to do that, now we're back in dangerous territory. But it does do that decoupling. The final 2 bullet points I hope are obvious. This is no substitute for communication. What this is an automated signaling mechanism to tell you that you've understood what the provider is giving you and tells the provider that the consumers are using, what the consumers are trying to do. There's an added benefit actually that isn't on this bullet point slide, which really should be, which is that many providers in the world have no idea who their consumers are. So I've worked in companies where we've got these services that we're running and we're not really sure who's consuming them. We can see that they're being hit, but we don't always know why. Whereas if you're getting these CDCs published, you're getting these pacts published, it gives you a really good indication of which components are dependent on you. And so if you want to make a breaking change in your provider, it then gives you a hint of who to go and speak to see whether it's really going to screw them up. And the final bullet point, it doesn't replace all other testing, so it doesn't get rid of any of the things that you're doing. It just makes the test automation pyramid reliable, because those tests at the bottom of the test automation pyramid demand a certain level of stubbing. And typically what we do is we fly by wire and we do occasional integration tests. This way you can build in confidence that those tests at the bottom of the pyramid are accurate. And despite trying really hard to go fast, I'm afraid I've run out of time and gone over. So thank you very much for coming along. I'll be around for at least the next 5 minutes.